This is a video on comparing the actual change in y, delta y, and the differential dy. The question states, evaluate delta y and dy for y equals x cubed minus 2x squared plus 3, with x equals 2 and delta x equals dx equals 0.01. So let's start with our delta y. And our delta y is the same thing as y of the final number minus y of the initial number. The initial number is 2, and I plug in 2, and I get 8 minus 8 plus 3, which is 3. Then I also need to plug in 2.01. That's x plus delta x, which is our final value of x. And I put that in a calculator, and I got that y of 2.01 was 3.0404. So delta y is the difference between those, or y of 2.01 minus y of 2, which is 3.0404 minus 3, or just 0.0404. Now let's look at dy. So dy is the tangent line approximation to the change in y. So let's start with the derivative, dy over dx, which is equal to 3x squared minus 4x. If we plug in 2, then we get 3 times 2 squared minus 4 times 2, which is 4. dy is dy over dx times dx. dy over dx is 4, and dx is 0.01, so we get 0.04. Notice that delta y, which is 0.0404, and dy, which is 0.04, are very close to each other. So dy is a very close approximation to delta y, as long as delta x and dx are very small numbers, like 0.01. Let's look at this graphically. If we look at a picture, the delta y is the actual change in y. So if I start from this point here at 2, and then I move along the curve, and I land at our new point at y of 2.01, then our delta y is going to be the distance, the vertical distance between those 2 points. For dy, instead of moving along the curve, we move along the tangent line. And when I move along the tangent line, I look at the vertical distance, and that's dy. Notice that the difference between dy and delta y is this line segment, which is very small as delta x approaches 0. It gets smaller and smaller and smaller. So that tells us that dy is a good approximation to delta y as long as delta x is close to 0. And I'm done with the problem.